We want to determine if each sequence converges or diverges. If it converges, determine what it converges to. To do this, we will think of a sub n as a function of n and determine the limit as n approaches infinity of a sub n. If the limit exists and is equal to L, the sequence converges and converges to L. If the limit does not exist, the sequence diverges. For the first example, we need to consider the limit as n approaches infinity of the quantity 12 minus 9n to the fifth divided by the quantity 2n minus 5n to the fifth. You may recall when determining limits at infinity of rational functions, there's a shortcut by comparing the degrees. In this case, notice the degree of the numerator and denominator are both 5. Because the degrees are the same, the limit is equal to the ratio of the leading coefficients, which in this case would be negative 9 divided by negative 5, or 9/5, or 1.8. But if we do want to show work and make more sense of the limit, we can divide each term in the numerator and denominator by the highest power of n from the denominator, which is n to the fifth. Let's go ahead and show this work. We'll divide every term in the numerator and denominator by n to the fifth. This gives us 12 divided by n to the fifth minus 9n to the fifth divided by n to the fifth, all divided by 2n divided by n to the fifth minus 5n to the fifth divided by n to the fifth. And now we simplify. 12 divided by n to the fifth doesn't simplify. Minus n to the fifth divided by itself simplifies to 1 here as well as here. In the numerator, we have 12 divided by n to the fifth minus 9. In the denominator, one factor of n simplifies out for 2n divided by n to the fifth, giving us 2 divided by n to the fourth. And then we have minus 5. And now let's consider the limit as n approaches infinity. 12 divided by n to the fifth approaches 0 as n approaches infinity, and so does 2 divided by n to the fourth. And notice we're left with negative 9 divided by negative 5, which is positive 9/5, or if we want 1.8. This indicates the sequence converges to 1.8, or 9/5. Let's look at this graphically. To look at this graphically, we'll plot points on the coordinate plane in the form of n comma a sub n. And now let's plot the first 50 points. Again, the y values of the ordered pairs represent the terms in the sequence, and we can see the y values or function values do converge to 1.8, or 9/5. And now let's take a look at the second example, which is a little bit trickier based upon the form of the formula for a sub n. Let's work on changing the form of this formula. Let's first write a sub n as 4 to the power of n plus 1 divided by 5 to the power of n plus 8 divided by 5 to the power of n. And now let's break off one factor of 4 from 4 to the power of n plus 1 and write 4 to the power of n plus 1 as 4 times 4 to the power of n. Notice we still have n plus 1 factors of 4 divided by 5 to the power of n, and then plus 8 divided by 5 to the power of n. And now let's change the form again and write the formula as a sub n equals, let's write 4 times 4 to the power of n divided by 5 to the power of n as 4 times 4/5 to the power of n, and then we still have plus 8 divided by 5 to the power of n. And now let's find the limit as n approaches infinity in this form. As n approaches infinity, 4/5 to the power of n gets smaller and smaller and approaches 0 because the base of 4/5 is between 0 and 1, and therefore as n increases, we multiply by more and more factors of 4/5, which gets smaller and smaller and approaches 0. So this part of the limit approaches 0, and then for 8 divided by 5 to the power of n, 5 to the power of n approaches infinity. As n approaches infinity, 8 divided by an increasing value gets smaller and smaller and approaches 0, which indicates the limit is equal to 0, and therefore the sequence converges, and it converges to 0. And let's look at this graphically. Once again, we'll plot points on the coordinate plane in the form of n comma a sub n. And now we'll plot the first 50 points. We can see from the graph the y values do approach 0, which is why the sequence converges to 0. I hope you found this helpful.